In the previous section, we described and listed shared resources on FPGA. By the end of this module, you will be able to share latest data between parallel loops running in the same FPGA VI using local variables, and share latest data between multiple FPGA VIs using global variables. Okay, so let's talk about sharing latest data. So if all you're wanting to do is share the latest data between multiple loops, what you can do is you can use one of these methods. You can use local and global variables, memory items, or register items. So in this particular module, we'll talk about local and global variables. So variables are block diagram elements that allow you to access and store data in the flip-flops of the FPGA. So by now, if you've come from using regular LabVIEW, you should already know local variables and global variables. But just know that when you use these on FPGA, it stores that actual data in flip-flops. So this is a good method to use if you're wanting to store only the latest data that you write to it. So if you need all historical values or buffered values, this is not a good method. This is only going to share the latest data or the most current data that you've written to it. So there's two types of variables that we're going to talk about on FPGA. One is going to be local, which is accessible only by a single VI, and there's also global variables, and those will be accessible by any VI that's running on the FPGA target. So local variables, they're going to store the data that's in front panel controls and indicators. So if you look at the bottom there, there's a stop button. If I wanted to share the value of that stop button within that VI, I could use a local variable for it, which you see right there. So on the right-hand side, you see the stop local variable. Local variables are only accessible within a single VI. You can also use them to maintain data separately for separate reentrant VIs or separate reentrant sub-VIs. The way that you can create a local variable is you can right-click on any controller indicator and you can select Create Local Variable, and then that will allow you to create that and place it on your block diagram. If you're using this approach, so if you're using local variables just to be able to share data between loops, you might find yourself creating controls and indicators only for data sharing within the VI that they're on. So if you're doing that, you might want to create a coding convention to help you distinguish which controls and indicators are used for simply data sharing and which ones are used for passing data in and out of the VIs. So if you're doing this, you might want to use global variables instead also, if you're only using a local variable and a control just for passing data. So here we see a local variable example. So here we have two parallel loops, loop 1 and loop 2, and the data that we're trying to share in this case is the value of the loop control. So if we look at loop 1, we have the loop control boolean right there, and in loop 2, we've created a local variable to read the value of the loop control, and that way we're able to stop both of the loops at the same time. Now let's talk about global variables. So global variables are also able to share the latest data. However, they are accessible through multiple FPGA VIs instead of just a single one. The way that you would create a global variable is you would go to the Functions palette and you would select Structures, Global Variable. Previously, if you were creating a controller indicator only to use the local variable for data sharing and you actually weren't really using that controller indicator, you can consider replacing that with a global variable instead, and that way you'll decrease FPGA resource usage because you don't have to implement that FPGA code that was just trying to pass data between the FPGA and host. Now you can share latest data between parallel loops running in the same FPGA VI using local variables, and share latest data between multiple FPGA VIs using global variables. Next, we will share latest data between multiple FPGA loops and VIs using memory items.